All right. Who's out there? Who's out there? Anybody got questions? Questions. Thursday is generally the busy day. This is the day the procrastinators like to get on here and ask questions. It's the day that my wife isn't here because it's her day to work. So, no questions. Hey, what's up? You go to sleep and then wake up for the stream, or you just stay up all night? That's the question I have. Do you just stay up waiting on this, or do you go to sleep, set an alarm to wake up? I was talking about you yesterday with my principal, or with one of my assistant principals that's in charge of the math department. Second choice. You just stay up, huh? But yeah, my principal, the assistant principal in charge of the math department, is quite impressed that a 7th grader is choosing to stay on and ask questions. Basically asking questions which is equivalent to Algebra 2. So kudos to you. Impress more than one adult. So, anybody got questions? If not, sorry Jay, but it'll be a short stream. I got to get back to Zelda. Get into the interesting part of the game. Got to go get the legendary sword, beat 2 more monsters, do some side quests, and beat Ganon. Should have that done by Monday. Then just start on the hundreds of hours of side quests. Zelda's my game. I've played every Zelda that's come out ever since, well, way before you were even born. So, anybody got math questions? Oh, man, oh man. Minecraft. I've never understood that game. You're just building stuff with blocks. Just get Legos. Maybe there's more to it than what I think. I think you're just building stuff with blocks. That's called Legos. $12:58. I started a little early for you. Just said 5 o'clock exactly on my side. Man. Anybody got math questions? It's not just building blocks. Still not gonna try it. But to go around and kill things kind of sounds like Zelda. Apparently in Zelda there's I want to be able to build a city soon. One of the side quests. It's an adventure. Huh. Kind of sounds like Zelda. It's an adventure. Can't really get into role-playing games that much, especially the new ones are so advanced. This Zelda one is just unbelievable. Gotta get diamonds. Bibiana. Wow, that's a name I haven't seen in a while. What are you up to, young lady? Where are you at? You graduated last year, didn't you? You're in the Navy now. Are you on a ship or are you on dry land right now? What do you do in the Navy? Besides sail? Oh, are you an actual meteorologist or you just kind of help with them? Because that's actually a good thing. You get certified and everything else through a meteorological society. That's good money, and that's a good thing. Good thing. You had to go through a lot of classes for that, I bet. Just got an email. I don't think anybody's got math questions today. Oh, YouTube told me I'm going live. So, Bibiana, you're just bored? So you decided to drop in on my live stream? Very impressive. Proud of you, young lady. Yeah, I do this Monday through Friday to help high school kids with their math, but not a lot of them come on here anymore to ask questions. I guess they're just kind of done with it. Oh, man. All right, so let me read this. Make a diamond, pickaxe mine. Well, Jad, I think you're talking a different language than me because when I'm reading this, I'm like, all right, so that you're giving me like instructions on how to actually beat something in Minecraft. Thank you, Bibiana. When it comes to explaining math, I try to make it as simple as possible because I know most people are not math people at all. I'm in a small group of people that understand math. Oh, you're telling me how to actually do the main mission in Minecraft? Well, yeah, I mean, if you actually told me the whole thing, but I'm not going to go play Minecraft. Just not going to happen. Man, ain't nobody got questions. Nobody's. Hopefully they turn all their work in. It'll be easy to grade. Two easiest things to grade as a teacher. A perfect grade, something that's perfect, or something that's not done. Everything else in between requires some work. So, Bibiana, did any of the math I have taught you helped you in your meteorology classes? I hope so. Chris, we did Pythagorean Theorem like 3 weeks ago with my kids. Well, I have a friend, a former student, and a 7th grader from Lebanon on here. None of my actual students or any students that could actually ask me real questions. I mean, if Jad over there in Lebanon decides to send me some work that he's doing, yeah, you're right. I did ding you capital letters because capital letters are actually points, not sides of triangles. Lowercase letters are sides of triangles. That's one of those little nuances in math. I'm going to show this to you. Most people don't get this. So capital A, capital B, capital C. So this is technically a point. And in geometry, you learn to label your points as capital letters. So all points are capital letters. So all vertices of anything are going to be capital letters. And then directly opposite, the opposite sides that are actually the lowercase. So if this is point A, which would end up being angle A, directly opposite is side A. And then directly opposite is side B, and directly opposite is side C. The hardest thing is for the kids to understand is the C's. In class, I have to write it as like a capital C and a lowercase c. I have to really exaggerate it because it's hard to tell the difference between the capital and lowercase letters. A and B's aren't terribly that bad. But that's actually why. I mean, I knew what you meant when you did capital A, capital B, capital C, but the nuances in math, it's so picky. And this actually leads to law of sines, law of cosines. In fact, Pythagorean Theorem, your a squared plus b squared actually has another part, minus 2ab cosine capital C would actually equal c squared. This is actually not really Pythagorean Theorem, but this is Pythagorean Theorem for all triangles, not just right triangles. It's actually called the law of cosine. But yeah, that's why I dinged you, is because I would ding any of my students that use capital letters in there, because this capital letter now is an angle. No, I totally agree, Bibiana. Most simple lower level maths are in most jobs. In meteorology, for a large part, it's computers are doing a lot of the calculation, the advanced modeling for you. But hey, Jad, believe it or not, in college they don't have a class called Minecraft yet. But I wouldn't be surprised by the time you got to college there was something in there like game theory or something along that lines, which is a math class. I know I've had some of my coworkers took a music appreciation class at Texas A&M main campus, and what they actually had to do is they had to pick apart Queen, the music created by Queen, and actually talk about how things are done like in a rock opera and everything else, because there was many layers to Queen. The group itself was actually a college course. There's college courses on specific movies. It's really, really kind of weird. In math alone, we have a class called Game Theory. Transversals and parallel lines, 8 and 15 of week. Okay, so 8 and 15. Cool. So let's dive into it then. But Jed, I'm saying I wouldn't be surprised by the time you get to college, they may have a class on Minecraft that actually blends in with the math, some sort of geometry, game theory math class. All right, so let's do number 8. So number 8, we have a shape like this. And then, for Chris watching, these are lowercase letters because these are sides, C and D. And then we say that this is 6x plus 1. I'm not going to write the degree symbol on there because it's just formality. And then 3x plus 8. Okay, so what this question is asking is, what value of x is going to allow us to say that line segment C and line segment D are parallel? So if we assume that they're parallel, we know that consecutive interior angles are supplementary. The best way to think about this is actually to draw these lines out and extend them out, because it's hard to see when it's in a shape. So if we extend the lines out and we erase this back part over here, we just have a basic setup of parallel lines cut by a transversal. Now, these are on the same side interior. Well, we have two options with this. Either they're going to be congruent, means that they're going to equal each other, or they're going to be supplementary, means that when I add them, they're going to equal 180 degrees. Well, the rule is with same side interior angles are supplementary. So we're actually going to add these two together, these two linear equations together, and they're going to have to equal 180 degrees. So I'm going to do 6x plus 1 plus 3x plus 8 equals 180 degrees. So that's the setup. From here, all we do is combine like terms and solve for x. So I'm going to have 9x plus 9 equals 180. I'm going to do something a little creative here. I see that there's a 9, 9, and a 180. I'm actually going to reduce this entire fraction by 9, which will give me x plus 1 equals 20. So what I did is I multiplied this entire thing by 1/9 to get rid of all the 9s. You don't have to do that. You could have subtracted 9 and then divided by 9, you get the same answer. But whenever I see something like this, I can reduce it that fast. It makes my math much easier. That's why in math we simplify, is to make the next step simpler, because this is a lot simpler to solve than this equation here. From here I just subtract 1 and I get x equals 19. So when x equals 19, these two angles, when I add them up, will be 180. This would actually allow us to say that C would be parallel to D. So not terribly bad. That's a horrible D. Not horribly bad. Just kind of having to know the rules. Are they congruent or are they supplementary? Congruent or supplementary from that aspect. All right, so that was number 8. And then the other one's number 15. And that type of shape was actually called a trapezoid because it has exactly one pair of sides that are opposite sides that are parallel. All right, number 15. So we have a long line here. They call this D, and then we have 3 lines going through it, and they call this A, B, and C. A, B, and C. Then they tell me this is 70 degrees. They tell me this is 70 degrees. And they tell me this is 110 degrees. And they want to know which set of these lines are parallel, or are they all parallel? So what we need to do is we're going to use these angles as references. So what I'm going to do is I'm going to fill in everything where it's congruent. So for congruent means we're going to alternate. So when I come underneath, I'm going to alternate. So 70, I'm going to use vertical angles here, which makes this 70 degrees. Those are congruent. Now we're going to alternate again on the inside, so it's alternating interior angles are congruent, so this is 70 degrees. So this alternates too. So because all of these are the same as they alternate down, we can say that A is parallel to B. Now, we can keep going with this. So we can alternate here as 70 degrees, and we can alternate here as 70 degrees. Well, these are all still 70 if this is parallel, but a quick check to see if this is going to be parallel is that these have to add to 180 degrees because they're supplementary. Well, indeed, 110 and 70 do add to 180 degrees. So at this point, we now know that B is also parallel to C. Now, there's a thing in math that we call the transitive property, and we can actually use the transitive property to say since A is parallel to B and B is parallel to C, we can now say that A is parallel also to C. So all 3 of these lines are actually parallel to each other just by doing vertical angles, alternate interior angles, vertical angles, alternate interior, vertical, and then supplementary. We can see that all 3, A, B, and C, are parallel to each other. All right, what other questions? What other questions? And Chris, if you're still on, you notice I'm using all lowercase letters for sides, for line segments and everything. That's that little nuance thing, the notation thing. And if my kids mess it up, it's 20 points off of grade, right off the top. But then they can mess it up 1 time or 50 times, it's still just 1 point off, 20 points off. First time I hit a kid for 20 points off for a notation mistake, you should hear the whining in my class. You're like, Mr. Buzzard, you know what I meant. Yeah, I know what you meant, but that's not what you wrote. But they only make it once because it's such a because I hammer them so hard on points. They make that mistake once and then they complain the rest of the year, but they never make that mistake again. I can hear one student right now in particular in my head complaining about me taking 20 points off. Check my mail. All right, Jad, let me see. I just refreshed it. All right. Huh. All right. Picture of your cat and some math problems. No, I totally get what programming. If you're off by a letter or off by a space, your whole program doesn't work. So you've got to hammer them, because if not, all that little stuff will completely make you can spend hours upon hours on a program and it not work because of syntax. I know when I program to create my worksheets like this. I actually program that into a thing called LaTeX, and if I forget one semicolon, the entire sheet won't compile, and it's just incredibly frustrating to have to go back and debug a program. All right, so Jad, what one of those problems do you want me to do? Pick one. These are all single-step linear equations. You just want me to do an example of them? Well, I'll work like 2 or 3 of them. They're all pretty much the same. Pretty straightforward. Let's do C. So you have an equation 3x equals 27. So to solve this, you're going to isolate x by itself. And to isolate x by itself, you have to look and see what are we doing to x. So we have x here, and because there's nothing written here, it's implied we're multiplying x by 3. So we want to do the opposite of multiplying. So the opposite of multiplying is division. If you can just remember PEMDAS, I don't know if you learned PEMDAS, but it's parentheses, exponents, multiply, divide left to right, and add, subtract left to right. Well, if we're multiplying here, we're going to do division. So we're going to divide by this number. The reason why we're dividing by that number is we want to get it to be the number 1. So 3 divided by 3 is 1, but the rules of algebra state whatever I do to one side, I have to do to the other. So here, 3 divided by 3 is 1. This leaves me just with x, which is 1x, and 27 divided by 3 just gives me 9, and that one's solved. Got a text message. My daughter sent me a TikTok. All right, so that's what you're going to do. Is you're going to look and say, what am I doing with this x? If you're multiplying, you are going to find what number it makes it 1, divide by that number. Most of the time, it's just a number right in front. So I'm going to use that as an example to do L, which I love how they changed the L. So you have a negative 4/11. They put the x on top, equals 5/7. Now, a lot of people would have a hard time struggling with this. I don't know why. Maybe they don't understand the concept of trying to create a 1. So what I'm going to do is I'm going to rewrite this with the x in front. And I have a negative 4/11 x equals 5/7. Now, there's a trick in math to create the number 1. That's called the multiplicative identity. We need to multiply something by its multiplicative inverse. Well, the multiplicative inverse is actually just the reciprocal. So like if I take 3, for example, if I took this is 3/1, if I take the reciprocal of this and I multiply by 1/3, that's always going to equal 1. So if I take 4/11 and I take the reciprocal of this and I multiply by a negative 11/4, that equals 1. So that's what I'm going to do is I'm going to multiply both sides by the multiplicative inverse to create the multiplicative identity. Big fancy words. But really what I'm going to do is I'm just going to take this one fraction, multiply it by the reciprocal. So I'm going to do negative 11/4 times negative 4/11x. Just take the reciprocal of it. You can do it all in one step. 5/7 times negative 11/4 is what you do on one side, you have to do on both. From here, this becomes 1, so we just get x. Here we multiply straight across. We are going to get a negative 55/7/4=28. So that's how you would solve that in one step. That's really the key with all of these problems. So if you have like 7x equals 4. So what I do is I multiply by the multiplicative inverse, which would be the reciprocal of this, which is 1/7, which is 1/7, which then this becomes 1/7 times 7 is just x, which equals 1x, and 4 times 1/7, multiply straight across, is 4/7. That's how you solve these one-step problems. Not a lot of people show this. They just say, oh, divide by 7. When they get here, they say, well, multiply by 11 and divide by 4. You get the same answer, but you do 2 steps. It's easier to do it in 1 step if you understand conceptually what's actually happening in these problems. So what else? What else? Believe it or not, while those problems are super easy, so many people do not solve them the best way possible because these are taught at a lower level math, and they're not really taught by math people. They're taught by teachers that don't have a degree in this, that don't understand the concepts of the theory of algebra. Because algebra has its own theory on how to solve these problems. And once you understand the theory, you don't really mess up your algebra, you mess up arithmetic, which is what I do a lot. I'll mess up my arithmetic in a heartbeat, but my algebra is generally pretty good. The thing that I knew today. By the way, your cat looks pretty cute. All white with a little collar, like a little ball sphere or whatever. So how's Ramadan going for you? That I am. What's up, daughter? You been doing your work at school? Hey, do y'all have a Minecraft game at LSU? A Minecraft course at LSU? You bet, Jad. So my daughter goes to LSU, Jad, and I'm asking her if she has a Minecraft course there. You just woke up for the day. Believe it or not, I took several naps today. It just figured it'd be something that it would sound like it would be a high enrollment class. Pythagorean Theorem 7D. Ooh, that is. Let me go find that sheet. That's from a while ago. Pythagorean Theorem 7D. Okay. All right, so on this, is basically, it gives me 3 sides. 36, 77, and 85. And it wants to know, do these 3 lengths of sides of a triangle, do these 3 lengths make a right triangle? So what I actually teach my kids is a squared plus b squared equals c squared. And the best thing to do is a is your lowest number, b is your middle number, and c is the highest number. If you do this, you'll never get these wrong, because this is actually not so much the Pythagorean theorem, but what's called the converse of the Pythagorean theorem. Whereas in the Pythagorean theorem, I give you 2 sides, you find the third. This one, I give you 3 sides, and you tell me if it's a right triangle. And c is always the biggest number. A and b doesn't matter, but if I tell my kids, hey, a is your lowest number, b is your middle number, and c is your highest, and they follow that same pattern every time, they never mess it up. So if we do this, we just do 36 squared plus 77 squared, and that has to equal 85 squared. This is a true-false math question. If this is true, then it's a right triangle. If it's false, then it's not a right triangle. It's either a yes or a no type deal. So let's do this. 36 squared off the top of my head is not happening. This is 1,296 plus 77 squared is 5,929. I add those 2 together, and I get 7,225. Now, I do 85 squared, and if it is 7,225, then it's a right triangle. If it's not, if it's any other number, it's not a right triangle. 85 squared happens to be 7,225. Therefore, this is a right triangle. That's all there is to it. Wow, I ran off the side here. It's the exact same number. You're just looking for the exact same number. Smallest number is going to be A. Do your middle number is B. Those are interchangeable, but if you always do it as this way, you won't make a mistake. And your largest number is always C. If it's a true math statement, it's a right triangle. If it's not a true, it's not a right triangle. That's it. What do you mean you burned to death? Talk about on Minecraft. You're seriously taking a jogging class? You're really taking a jogging class? Well, I can't say anything. I took a volleyball class in college. I almost got kicked out of it, in fact, because it was a non-competitive volleyball class. I don't know if you remember because you were little, but I almost got kicked out of it because I was yelling at my teammates because they weren't putting in the efforts to win. I get yelled at all the time. But if you're playing a game, you play to win. You don't play to have fun. That's like the wrong mentality. You don't play games to have fun. You play games to win. You seriously are taking a jogging class? Hello, Adam. So I just found out my daughter's enrolled in a jogging class. Unless she's pulling my leg, because Tyson's her dog, and I don't think they're letting the dog enroll in LSU classes. Although there is an ongoing thing that he is a liberal because he is majoring in dog studies. Yeah, as long as you're winning, winning's fun. Losing sucks. Completely agree. I don't understand, like, this modern world. This modern world where everybody's a winner. No, there's one person that wins and everybody else loses. I remember one time my daughter had the highest grade in all of 7th grade math algebra, and I went on Facebook and congratulated her, and everybody's like, oh my God, everybody else did so great. You shouldn't be so competitive. Yeah, my daughter goes to LSU, so her 15-0 is a comment about their football team this year. Yes, indeed. Like, everybody gets a trophy. I don't get that. I don't. Because then it doesn't really teach them how to compete. You literally learn how to compete as a child, so when you get into the adult world and you're competing against other adults. Slender, I don't know. Well, what's up, Slender? But yeah, when I was raising my daughter, I taught her to compete. I never let her just win at anything. She still today has not beaten me in a game of backgammon. Oh, I got a bunch of people popping on. Mama Oto Gaming. Bunch of different people on here. But yeah, I always believe that kids should learn how to compete, learn how to win and lose. You did come close, and I still have the video where you came close. Rivalries are good. They're great motivators. Asked my daughter about rivalries and how she absolutely loves Alabama. I have the sarcasm. I did get lucky. I mean, granted, I have a 1 in 6 chance of rolling doubles, but it was that 1 out of 6 chance. It might be several people with different accounts, but whatever. It all counts for total time on this. It doesn't matter. But yeah, I mean, when you're an adult, everything is a competition. Everything's a competition. I teach teaching as a competition. I want to be the best teacher. I'm competing against all the other math teachers, competing against every teacher in the school to be the best. Yeah, whenever LSU plays Alabama. They have Bama Hate Week, and my daughter sends us pictures all the time of stuff that they're putting up around campus because of their rivalry. Anybody got any math questions? I really think it's the same person then. Creating different accounts and popping it on. Jad, are you messing with me? But yeah, even a job interview is a competition. You're competing against everybody else interviewing in the job. Are you just creating accounts just to log in? Telling me. Stop acting like a 7th grader. Do 2 and 3 from supplementary angles. Yeah, sure. I gotta find it here. Wait, there was a list of word problems, right? I'm trying to remember, I have so many different things here. Not that. That's algebra 2. That's algebra 2. Here we go. All right, found it. All right, let's see. So 2 and 3. So 3644. Okay, so number 2 reads, 2 angles are complementary. One angle is 5 times the measure of the other angle. So what I'm going to do is I'm going to say the measure of angle 1 equals 5 times the measure of angle 2. Because one of the angles has to be 5 times bigger than the other one. And then the measure of angle 2 equals the measure of angle 2 because it's just reflexive property. Now, because they're complementary, that complementary means they're going to equal 90 degrees. So the measure of angle 1 plus the measure of angle 2 equals 90 degrees. Now, I can play the substitution game. I know the measure of angle 2 is the measure of angle 2, so I'm not going to mess with it. But I know the measure of angle 1 is going to be 5 times the measure of angle 2. So I can replace this measure of angle 1 with 5 times the measure of angle 2 plus the measure of angle 2 equals 90 degrees. At this point, we can combine like terms. You can change these to x's, I don't care. But the measure of angle 2 is a variable. We're trying to solve for it. So we're going to combine like terms. Well, I have 6 measures of angle 2 equals 90 degrees. Divide by 6 on both sides. We get the measure of angle 2 is going to be 90 over 6. You can reduce that fraction by 6. 96 should go into 90. Goes 15 times. So the measure of angle 2 is 15 degrees. And then the measure of angle 1 is going to be 5 times 15, which will be 75 degrees. So measure, one of the angles is 75 degrees, the other one is 15 degrees. All right, so that is number 2. So we finished that at 38.56. And then you wanted 3. All right, let me erase and we'll do 3. Yeah, but 9 of them are probably you, Jad. All right, number 3. It says one angle is 25 degrees bigger than another angle. So let's do the same thing. The measure of angle 1 is going to be the measure of angle 2 plus 25 degrees because it's 25 degrees bigger. All right, the 2 angles are supplementary. Okay, so since they're supplementary, Well, let's do measure of angle 2 equals the measure of angle 2. Since both angles are supplementary, that means they're going to equal 180 degrees. So we have the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Same trick. Measure of angle 1, measure of angle 1. Replace it with this measure of angle 2. I have the measure of angle 2 plus 25 plus the measure of angle 2 equals 180. Combine like terms, I have 2 measure of angle 2s plus 25 equals 180. Now let's solve. Subtract 25 from both sides. I have 2 times the measure of angle 2 equals, let's see, goes to a 7, 5, 155 degrees. Divide by 2. The measure of angle 2 is going to be 7, 15, gives me 7, 14.5. So 77.5. So the measure of angle 2 is 77.5. So to find the other measure, we just add 25 to this. We got a 0.5. This is a 2 carry. That becomes 3, 102.5. So my two angles are 77.5 and 102.5. So it's the same idea. It's really the same idea as the last one. It's knowing how to set these up, writing a linear equation, and then knowing this idea if it's going to equal 180 or 90, and then just substituting it in and solving. What else? What else? What else? Alex, did you really enroll in a jogging class? I mean, it's a PE credit, but I can't see you jogging. I think she's mad at me now. Guess it's about time to go play Zelda. You're not in a jogging class. I could not see you in a jogging class, to be honest with you. So, Chris, you think the pool halls are going to open tomorrow since the governor's lifting the stay-at-home? Probably need to call Chong to see if he's planning on opening. Give me something else to do besides play Zelda. Man, it's killing me. I have all this free time that I could actually go and work on my game and run some drills, and I can't get to a pool table. Pythagorean Theorem 4a. Alright, Pythagorean Theorem 4a, 43. Here comes Coda. Alright, so we have a right triangle, and this is 10, this is 28, and they say this is A, and it basically wants you to solve this to the nearest tenth, so 1 decimal place. So, of course, then we still have our A squared plus B squared equals C squared. My C is always directly across from the 90 degrees, so this has got to be my C. It doesn't matter what these are going to be, but since they put this as A, we might as well leave it as A and count this as B. So we can do A squared plus 10 squared equals 28 squared, and all we're going to do is solve for A. Let's see. He walked off, Jad. So A squared plus 100 equals whatever 28 squared is. 28 squared is 784. Subtract the 100 from both sides. We have a squared equals 684. And I write it 2. Take the square root. When you do the square root, you always must remember the plus or minus. Even though in geometry it'll always be the plus one we're going to choose, because now the reason why I say that is when you get into algebra 2 or higher up, that plus or minus will actually make a difference in your answer and how you would actually answer the question. And I want you to get in the habit of doing the plus or minus every time you take the square root. But because a is a length and length is never negative, we actually know it's going to be the positive. So a equals the square root of 684. Now I said round it to the nearest tenth. So you actually don't have to break this down. Yeah, length is positive. See you later, Chris. So from here, you just simply do the square root of 684. And this is approximately 26.153, blah, 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 blah. Now you need to round. Your tenth spot is here, so we're going to look at our 100 spots here. The rule is, if it's 5 or greater, we add 1 to the tenths. If it's 4 or less, 4 to 0, we leave the tens place alone, but because this is 5, we're going to add 1 to this position. So my answer would be 26.2. That's it. That's it, that's it, that's it. What else, guys? Hey, Alex, text me how much your rent is so I get it paid for you. I always forget your actual number, and I don't know the login to pay it. But I'll go get everything for it to get it paid by tomorrow. Coda. I just can't go pick him up because if he doesn't want to be picked up, he'll bite you. All right. Text me then. Let me go get Coda so you can see him before I log off. We got 13 minutes left. I'll be right back. Hopefully I don't get bit. Coda. And he was mad because he was trying to go back to sleep. But he didn't bite me, so that's a plus. Alex says hi. Alex says hi. Do you believe that she was going to put Tyson in a jogging class? Do you believe that? No, because he's lazy. And he doesn't know how to run. Phi B from Pythagorean Theorem. All right. All right. Chill out right there. Phi B. Huh. Get a real degree. I have a degree in math. I have a real degree. All right. So we've got a circle here. Why a dog's trying to lick me. And coming from the center of the circle. Are you done? Are you done? Hey, you done? Can I do some work now? Dude, seriously. All right, and then we have a triangle coming out of it. That's a right triangle. This is 25. This is your radius. This is your radius. And this is 35. Okay, so this is really just Pythagorean Theorem. But what we need to know is directly across from here, my C is this entire length right here. So that is actually going to be R plus 25 because of segment addition postulate. I can add those together. So when I set this up, I'm going to have, let's call this A, let's call this B, and of course this is your C. So we're going to do A squared, which is going to be R squared. Trying to lick me while I'm doing math. R squared plus, what are you doing? All right, you know what, now. And he comes right back to me. R squared plus 35 squared equals R plus 25 squared. All right, from here, we're just going to solve for R. Now, granted, this has got quadratics in it, which is a little bit more difficult. We have to FOIL this out, and I will show that over here. But we're going to have R squared plus whatever 35 squared is. 35 squared, 1225 equals, now let's FOIL this out. I'm going to show it to you. I'm just going to do traditional FOIL. R plus 25 times R plus 25. I keep saying FOIL because that's an acronym for first, outer, inner, and last. That's the order we do this in. So first, R times R is R squared. Outer, R times 25 is 25R. Inner, 25 times R is 25R. And outer is 25 squared, which is 625. We combine like terms, I get R squared plus 50R plus 625. All right, so this becomes R squared plus 50R plus 625. In algebra, there's a thing called the cancellation property because this is a positive R squared being added. Positive R squared being added, these cancel, or you could just subtract R squared from both sides, they'll go away. Then we're left with 1,225 equals 50R plus 625. Subtract your 625 from both sides. 0, that's a 0, that's a 600 equals 50R. A 0 goes away. Now I have 60 equals 5R. Divide both sides by 5. And my R is going to equal 1. R equals 12. There you go. So this one's a little bit more complicated than the last one we did because you actually had to FOIL in. What's nice is you didn't have to solve a quadratic because it's set up where the squares actually fall out and turn it into a linear equation. You can type T both ways. Yeah, uppercase, lowercase. Called the shift button. All right, what else? We're coming up on our hour here. What else? Man, he already went back. He went back there to go back to sleep, laying down on the bed or the couch out there. All right, guys, I think I'm going to call this. It's been 54 minutes. I actually answered some math questions. It's the second one, Koda, K-O-D-A. That's his actual, how you spell his name. It's Koda. The capital K, it's capital K. I will enjoy playing Zelda, even though I'll get frustrated. I love how my daughter's yelling, "It's Coda." Yeah, okay. My daughter calls me a boomer. Don't make me block you, Jad. All right, guys, I'm out. I'll see you tomorrow. Well, yeah, I'll see you tomorrow at 5.